Hello everyone, my name is Dimitrios Doudesis and I'm the last thing between you and a nice cocktail. So bear with me, it's the last talk of the day. Also a lot of my slides you have seen them before, so it's like revision time as well. So every year 5 million patients present to the emergency department with the primary symptom of breathlessness, and this counts around 5% of all hospital admission. So the evaluation and the treatment of this patient costs to the NHS in the United Kingdom around 400 million pounds, which I think is consistent with the previous slide, so good for our data. Also, the most important thing is that most patients are being diagnosed with acute heart failure following an episode of acute breathlessness. And we know that these patients have quite high mortality at the first year, around 40%, if they have not, if they don't receive broad treatment and diagnosis. So why it is challenging to diagnose acute heart failure? So first of all, there are other life-threatening conditions that they have very similar symptoms and signs. And although we have some blood natriuretic peptides to aid with the diagnosis, at least in the United Kingdom, the natriuretic peptide testing is not quite applied, with like 1 out of 3 hospitals only offering this service, and the numbers of actually tests are actually way lower than that. And that's besides the guideline recommendation where they suggest to use these biomarkers to diagnosing this disease. Now, the reason behind we assume that this has not been universally adopted in clinical practice is that it's a test, it's a binary test, usually a single cutoff threshold that provides a yes, no, and although we all do research with thresholds, I don't think you use thresholds in your clinical practice. And the reason is because a uniform threshold will offer individual variation. We're all different, and a single threshold cannot apply to all of us. So when you're seeing a patient, you're taking all these factors into account. And this creates quite a diagnostic uncertainty around these guideline recommended thresholds, and hence not being used. So to address this problem, we perform a systematic review meta-analysis, and we collect data from over 10,000 patients around 13 countries around the world to provide a solution. A solution called CodeHF, which you have already seen, was published last year in the British Medical Journal. And there we combine NT-proBNP values with clinical variables that we're going to see in the next slide. But the main message was the CodeHF is a decision support tool that rules in and rules out acute heart failure more accurately than any approach using NT-proBNP thresholds alone. Now, NT-proBNP is the most common natriuretic peptide used, and what we thought to do this year was to actually develop and evaluate CodeHF for the other natriuretic peptides, such as BNP and MRPNP. Now, I think you have seen this slide 5 times today. CodeHF combines 10 objective, however, clinical variables using machine learning to provide an individualized approach. And this is also the app that, again, you have seen. And we have discussed, again, about the functionality that offers to the hospital to allow different rule-in and rule-out criterion to adjust about how conservative they are, or the clinical resources, or any other settings that they want to set. So we can move on to the new things, and that is the how the biomarkers perform. So first we need to highlight the problem. And I have seen in many slides that the uniform threshold works perfectly, but I have data that proves otherwise. And we can see here that this is the BNP biomarker recommended guideline threshold of 100, and how it performs both when it comes to rule out and rule in. Quite heterogeneous performance, both for NPV and PPV, but also overall performance below to what we consider appropriate. For example, a negative predictive value of 98.5% and a positive predictive value of 75%. And without no surprise, the same thing applies for MRPNP. Heterogeneous performance, overall performance below what is considered standard or acceptable for most settings. So by applying the same methodology, we want to create an algorithm, CodeHF, that can be applied to any setting that they use any biomarker. We developed CodeHF, we incorporated to CodeHF BNP. Now, in my slides, you're not going to see raw curves because raw curves is something very easy to achieve a high performance. You can see the area under the curve here. That is both quite high for both patients with and without previous heart failure, AUC of 0.91, AUC of 0.85. However, what you can observe here is calibration, and we have a quite great calibration to the whole range of CodeCS scores. And allow me to tell you that this is the weakest point of a lot of decision support tools algorithms out there. When you have a good calibration to the whole range, you can use your scores to the whole range. In the raw curve, you select 1, maximum 2 points, and you only choose those, not the whole range of raw curve. Moreover, we managed to achieve homogeneous performance to every subgroup and also achieve the pre-specified targets of an excellent negative predictive value and positive predictive value, while for BNP managed to rule out 60% of patients with, again, as I said, excellent negative predictive and positive predictive value. And moving on to MRPNP, again, similar concept and as you can see, similar performance, excellent area under the curve, 0.93, 0.86, but again, the most important thing is the calibration here, calibrated quite well to the whole range of scores, which implies that it can be used for the whole range of score, not only a threshold. And of course, homogeneous performance to every subgroup, while in this case, with this biomarker, it has a bit better rule-out performance, where it ruled out almost 50% of patients, again with an excellent negative predictive value of 95.5%. And it ruled in 30% of patients. Now, the rest of the slides is I'm going to present like the pipeline of the projects that we have run the past year. And I will start with our prospective validation of the CodeHF algorithm. So because it's a very common limitation to develop something using retrospective observational data, we thought that the next step towards our goal to implement actually CodeHF into clinical practice and actually use it was to prospectively validate. So by collecting data from every patient that presented with breathlessness to the Royal Infirmary of Edinburgh, we collect their data. We ask an experienced clinicians to adjudicate their diagnosis of acute heart failure. However, these clinicians were blinded to the NT-proBNP values, which we measured in the background. Next, we ask Datalog that Nick introduced. It's our data provider that allow us to do the data linkage for primary and secondary care for patients in Scotland. So the idea, and this is where we currently at, is to provide the data log to all the values of NT-proBNP, the adjudicate diagnosis, and all the primary and secondary care data of our population to provide us a quite good and clean and complete data set to perform our prospective validation. Hopefully this will be achieved in the next couple of weeks. Now, moving on to the last part before our ultimate goal, which is a randomized controlled trial, is actually to implement CodeHF to the hospital. So the app that you have seen, it's nice, and you can play around it. I have, again, the QR code, if you haven't already scanned it at the last slide, that will take the prototype and will actually integrate it to the hospital electronic health records. So we will, right now, we are like halfway there, I would say, Nick, that we have combined lab data, electronic health record, patient, and we're working on ways to actually get this information into the cloud, get this as an input to the algorithm, and return the probability to the clinician using a clinical dashboard that we are creating in combination with clinician research nurses, because first we want to create a product that will be used and the users are not us, the researchers, but actually are the clinicians in the hospital. And yes, of course, as part of this translational world, we need and we will submit for regulation approval to get UKCAC marking in order to use this tool, but we will do it for all the biomarkers, anti-BNP, BNP, and MRPRNP, which I have to say I learned about BMP10 today. So yeah, if you have data, call us. So in summary, I would like to say that we have now developed CodeHF and validated to be used with all natriuretic peptides testing. And we believe that it will improve the utility of these natriuretic peptides when it comes to the diagnosis of acute heart failure. We think that CodeHF will improve the triaging of the patient, healthcare utilization, and patient outcomes, because it can rule in and rule out acute heart failure more accurately than any natriuretic peptides threshold process alone. This is the course code. And I would like to thank the CodeHF research team and, of course, our collaborators for their data and value. And I will welcome any question. Thank you very much.
Yeah, thank you very much. Also, a very nice talk and very convincing data. So there's the first question just up there in the first
thank you very much.
Row.
I'm really impressed at the effort we are doing after 20 years of evidence that, doctors still, 1 on 3, don't trust BNP and TproBNP. I appreciate your effort because you are trying to demonstrate the value. My question is to you, do we really need this to convince these people? So you say that 1 over 3 of people, doctors in UK, are not using natriuretic peptide. This is crazy, absolutely unacceptable. In Italy, I lead an association of patients with heart failure. Immediately, they go outside the government, say, are you crazy? You don't. So I appreciate scientific point of view, but I think, are you sure that once you are nicely demonstrating the value of this technology, doctors will change their mind?
So that's an excellent question. And I think first we need to change, first of all, disclaimer, not a clinician, but I think first we need to first make available this biomarker testing to the hospital, because if you cannot test it, you cannot learn it. But and then it's actually our time now to convince that you cannot. Ah, thank you. Thank you. I won. I won. Drinks on me.
Okay, Alex.
Yeah, thank you very much indeed. It's great results. My question is for you, but maybe also to the people in your writing committee. For the next trials in acute heart failure, do you think regulators, companies are ready to switch from one inclusion criteria to the score as inclusion criteria?
That's a very good question. I'm not involved with companies and how RCTs are set up, so I don't think I can answer this question. But what I think we should do is find the best approach that will help us target the right patient and drop down the mortality rates, improve treatments, and all this kind of stuff. Because clearly what we're doing now is not working.
I have a practical question. So I scanned your code previously, and the first thing I had to do is to fill in my credit card number. Is this something which may be also a hurdle for the use in UK or in other countries?
So, sorry, what is the question?
So when I scanned your code, your barcode, yeah, I asked for the credit card of Christian Müller, and he said, "Okay, the Swiss, the Swiss currency is better than the euro." No, just kidding. So now I ask, paying for the use of the app, is this a hurdle, or maybe the hospitals, are they paying for the doctors who are working at the hospital? So is this a hurdle to use it?
If I understood correctly, I think the way that's going to be rolled out in the hospital will vary. This can be easily be incorporated by a company that sells the test, so it can use the tool in order to increase the sales of the NT-proBNP, for example, or BNP, but also this can be brought from NHS in the UK to actually improve the way that we're actually using the test. So there are many ways that this can move forward. It can be from NHS or companies or both. But yeah, I think the future will decide how we're going to incorporate it.
There's another question over there.
Nice presentation. If I understood well, this is an algorithm to be used for patients with shortness of breath, right?
Yes.
So I think that natriuretic peptides still stand the diagnostic tool for those patients with acute heart failure not complaining of shortness of breath, which is more than 50% of them. They just come to the emergency department because of increasing in the legs diameter, etc. But dyspnea, which is frequent in acute heart failure, I think is not it's not universal. So I think this has to be remain clear. This is just to apply for those complaining of shortness of breath.
Yes, and again, I agree, not a clinician, but I think if the clinician is suspecting acute heart failure, they can still ask and measure NT-proBNP or any other biomarker.
Okay, I don't see any additional questions. I think we are a little bit over time, but it's not because of the last session. it's the whole day. So I think we had a very nice day, also with very nice presentations from young researchers in the last session. And